So it's 51. So from here, you can get the D to find the EOD. Okay, negative 29.589. Right, so fast. Okay, EOD negative 14.2833 minute. Then we can find the TC, time correction factor. Others, please check your answer with answer from GA. If any different, just let me know. We discuss together. Okay, so this one you have to be very careful because you see that the longitude now is a west. Okay, so if west, you have to put negative. So the longitude is negative 74.006 minus 4 times 15 degree plus EOT. Okay. Negative 70.3073. I think I want you to do this because of the longitude. So whenever you see the west, then you have to put the negative. Okay. You can see that you positive, totally you have get different answer. Okay, 13.8449. Or if I write in minute, hour and minute will be okay. So from here, from the solar time, you should able to determine the hour angle H. Hour angle will be local solar time minus 12 and multiply with 15 degree. Okay, what's your answer for H? Hour angle. 29.75. Sorry, I haven't recorded. Uh, okay, 29 point something. I get 29.9. 29.75 okay. Okay, because we round out a little bit. Okay, so once you get H, then I think it's time to find altitude and azimuth angle. Okay, so let's say find altitude angle, sine alpha. Seems like we're still missing declination angle. So declination angle. Negative 11.58. Okay, then you can find alpha. Latitude also same thing. If north, then you use positive value. If south, we use a negative value. GA very fast. So alpha 16.8382. So once you get alpha, then you can get the Z azimuth angle. Oh, wrong. Okay, never mind. We wait for other answer. $30.91. How about others? Same answer. Okay, good. Okay, so one get alpha, then the next step is to find the Z azimuth angle. We have all the information already. Just substitute inside. $34.51. Okay, 34.51. So when you find the azimuth angle, you should be able to identify where is the location of the sun. Okay, north. So here is New York in middle, and location of sun is at which point? First, second, third, and fourth. We just know that the angle is measured from the north-south axis or the polar axis. Okay, 34.5147 is measured from polar axis, but you also can measure from the first quadrant, second quadrant, third quadrant, and fourth quadrant. So think about it. Now the sun is located at where? Which quadrant? 1, 2, 3, 4. Because just know the value of Z is useless. You must know exactly the location. Okay, what's the meaning of 34.55 on this Z? Anyone think about it? The depth should be measured from the first, second, or third, or fourth quadrant. Q3. Oh, okay. So first, we know that the sun will move from east to west in the morning. Okay, morning it will go up east and to the west direction. Okay, so this is a morning or afternoon. We look on the solar time, don't look on the local time. We look on the solar time, 1:59 p.m. So from the east side, definitely up because this 1 and 4 refer to the morning. So we have 2 and 3 only. So 2 and 3 now we want to see the sun pass through the north of New York or south of New York. Then we have to check the location of the sun and the location of New York. The location of New York is 40° north. I think we don't need to check the location of the sun anymore. This must be definitely at the south. Okay, because the location is very high in the north hemisphere. Okay, and remember that declination angle maximum up to 23.45. So that we can say that New York is always at north. So that you stand at New York, the sun will pass through the south of New York. Okay, so Jie and Han Xiang, you get the correct answer. It should be in first third quadrant and give you angle 34.51 degree. Okay. Okay. Can you follow? No question, then we can move to the next one. Okay, then we move to the next question. When are the dates for solar path 1 and 7? Okay, so this question is a bit special. The legend is not given. Give you a number only. 1, 2, 3, 4. Yeah. 1, 2, 3, 4, 5, 6, 7. Okay, now you need to find line 1 and line 7. Okay, so first we check on the location. The location is as Bolivia. The coordinate is 16.2 south and 67.4 west. So what is the date of 1 and 7? Okay, so in that case, so first, you need to know direction. The sun, we know that it moves from east to west, and east in the morning, the azimuth angle will be negative. So this one, I can say east, and this is west. So the direction for 1 is north. So the sun will pass through the north of this location at the date 1. Okay. Okay. If you compare line 1, line 2, line 3, and 4, and 5, what is the difference of line 1 compared to the rest? You can see that they have the lowest azimuth angle. Sorry, lowest altitude angle. Okay, lowest alpha at solar. Lowest value of alpha represent it is a location furthest away from the sun. Okay, so if you draw out the Earth, this is the equator line, and we want to draw the location. Left us is here, which have the angle. Excuse me, 16.2 to the south of the equator. Okay, so we know that the sun will move with the angle 23.45 to the north and 23.45 to the south. Are you able to identify the date for these two lines first? So when the sun will hit on the north hemisphere, when the sun is closer to the north hemisphere will have the summer. Okay. When the sun is close to the south hemisphere will have summer. And at the same time, the north hemisphere will have the winter. So if you know a little bit about the season in the country, the four seasons in the country, okay, then you can estimate around when you have the summer. When you have the summer at maybe Europe country or when you have summer in China, okay, so it should be around mid of year, all right? So it should be June 21. Again, when you have the winter at in China or in Euro country, so you have December. Normally end of the year, we have the December. And the middle line, we have the 1st of September and the 1st of March. Okay, so that I know that at point one, the sun passed through the north of this location, and the it has the lowest alpha at Solana. So that I will say the sun passed through the north of the location, and it will be the furthest away. Okay, so I will say line one is actually 21st of June. You can see that for the entire year, during this point, the sun is getting furthest away from the location. Okay, and through the north direction. That clear, settled. Then we look on the line 7. Line 7, same thing happened here. This is a negative azimuth angle. So it's in the morning, east. And the other side is west. Okay. So if I want to draw a direction, here will be south. So it means that the line 6 and 7, during the day, the sun will pass through the south of the lattice. Okay. So when is the date? 21st of December, which is the lowest altitude angle at Solana. Okay, so line 7 is 21st of December, and line 1 is the 21st of June. Okay, any question on the tutorial 2? I think this is the last question on tutorial 2. If no question, then we can move to the next one. Can follow? Okay, no issue on? No response, I mean, it's mean no issue on? Then I can proceed to the tutorial 3. Okay, let's look. Chongyi, do you mean the last question? I think it's a newly added question, I guess. Okay. Then we look on the tutorial tree. Tutorial tree. First question. What are the factors affecting the efficiency of the solar thermal collector? And how can we improve the efficiency of the solar thermal collector? Solar thermal collector is an old technology where we use the heat from the sun to boil the water and run the steam turbine. Okay, any idea how we can, okay, what is the factor? Okay, and then together with the how we improve based on the factor. Maybe think about it. What are the factors affecting the efficiency? Anyone type your answer in the chat box. Panel cover. Okay, fine. But there to be more specific. What do you mean by panel cover? Whether transparency of the panel cover, or maybe the material of the panel cover. Okay, what you need to do about the panel cover? It must, what condition or what properties that you have. So they should have the very good transmissibility. Maybe, for example, low iron glass. Okay, and you should have a low absorptance index. Okay, high transmission, low absorption, and low transmission. Sorry, low reflection. Okay, so this is what we look for. And the function of panel, of course, is to avoid the heat loss due to the convection. So you do not want to have any blockage by the cover. Okay, so cover is a good thing for most of the case, but for the case that have location which have the low convection rate, then the cover is not a necessary item. Okay, other than cover, how about cloud or maybe condition, atmospheric condition? Do you think that the cloudy day, the condition of the cloud will affect the efficiency? This one is very dangerous if you use this point. Because when during the cloudy day, you get very low output. But low output doesn't mean that you have the low efficiency. Okay? Low output is due to the low input of the cloudy day. Low input, low output. The efficiency can be even higher. The reason is when you have a cloudy day, the water is not hot. Temperature difference between the water and the surrounding is closer. So that the heat transfer rate or heat loss, the rate of heat loss will be lesser because of the smaller temperature difference. So in that case, cloudy day should give you better efficiency. Okay? But lower output. Okay? That's why we don't like cloudy day, because efficiency is not the main issue, but we actually more focus on the total output. Okay, what else? How about the fluid inside the collector? Will it affect anything? Okay, the fluid inside the collector must be have very high heat capacity. Yeah, okay, you want to use methanol. Okay, but methanol, okay, what's a good thing about methanol? Methanol have very low freezing point and is light density. But the advantage is it won't freeze. You have two-phase liquid, okay? But the disadvantage is you have much lower heat capacity compared to water, okay? But in terms of to use in the evacuated tube, this methanol is a very good idea. Okay, because it can change phase very fast at the lower temperature. Okay, which will carry the heat to the heat exchanger. But for the solar thermal collector, the flat plate collector, normally won't use methanol because the capacity is lesser, the heat capacity is lesser compared to water. Okay, but it have the anti-freezing characteristic lah. Of course, this is another condition advantages of this methanol. And what else? The insulation. Okay, you can talk about the insulation. We can talk about the pump speed. Okay, flow rate, flow rate of water inside the tube. And what else? I think normally, as long as you can think of three, then should be good enough. Okay, but I think this one, they have a lot of factors will affect the efficiency of solar thermal collector. Okay, how about spectrum? Light spectrum. Do you think that because at different time the spectrum will be slightly different, even at different location, the spectrum of the sunlight will be different? This is because at different location the atmospheric condition is different, so they will filter out different part of the light spectrum. Okay, so in terms of this heat, normally some wave, some of the spectrum will have the better heating power. For example, infrared. Okay, but you see UV actually do not have much heating power. That's why different spectrum will have different function. So that if you have the different function, different spectrum fall on the panel, then you should get the different efficiency. Because when you measure the input, you measure the total spectrum. You are not measuring a specific spectrum only. Okay, they definitely will affect the efficiency, but it's not what we can improve. We cannot control the spectrum of light. Okay, I think enough lah for this. Okay, look on the second question. Solar tracking collector has been widely used in concentrating collector. Suggest a mechanism or system on how to track the solar effectively. Now you have the solar thermal collector. It's not the solar thermal collector. You have the solar tracking collector. It can be the photovoltaic panel, can be solar tracking, solar thermal. Then how you want to trace the sun? In general, we have two methods. Okay. First method is we use the sun tracking system where we have a sensor, maybe a photo sensor. Okay, but of course, one photo sensor is not enough because the photo sensor normally will tell you, yes, I have the value. What value is it? Yes, I don't have value. Okay, it won't tell you that where's the location of the sun because at the different time, different location, the solar irradiance will be different. So you cannot say that when the photo sensor receives whichever amount of sunlight, then that is the direction. No. So normally, I think they'll use a few photo sensor. Okay, if you put on different location, and then they rotate until all of them get the maximum value. Okay, that is referred to the direction of the sun. But this method is not very effective during the cloudy day because at the cloudy day, the sunlight is mainly diffuse radiation. It's changed direction by the cloud. So that to find the location of the maximum solar irradiance is very difficult. Almost the same. You point to the left, point to the right, actually you will get the same. So somehow you're waste of energy. You turn around to find the maximum point. But it's actually not valid. Okay, unless you have the better design the system. When you cannot find it, then you don't find it, you fix to a certain point only, then okay lah. Or very many, maybe below certain value, you can stop from tracking. Okay. Another method is use what we learned in the lecture. We use a calculation. We know the azimuth angle. We know the altitude angle. Okay, based on these two angles, we always can identify location of the sun accurately. Okay, so this is another method. You maybe use a MATLAB to control your movement. Okay, and add in the value. At 11:45 p.m., where is the location of the sun? At 11:50, where is the location of the sun? Then you rotate accordingly. This is the better way. Okay, but if you have better way, maybe another one, maybe you can just connect your controller to the Google. I don't know whether you can make it. I think it should be okay. You get the reading from the Google. Okay, that will be more accurate, the real time reading. Okay, because whatever we calculate, we make some minor assumption. It was slightly different from the real value, maybe point something, a very small difference. Okay. Okay, let's look at question number 3. I think question number 2 just a little bit explanation. Question number 3. You are at the climate conference in Copenhagen going on in December. Okay, which the location is 55 degree at the north latitude. In what direction angle will you point your solar panel? Okay, think about it. What actually you want to calculate? You are in this location in December. Okay, first, direction. Where you want to point? You want to point to left, sorry, north, east, west, south, or in between them? South. Okay. Zhongyi, that's very correct. You face the south. The reason is the location is located north, 55-degree north. So to get most of the sunlight, you should face to the south. Okay, but why face to the south but not certain angle? Because you see, the time is not given. When the time is not given, you have to face to the solar moon. Okay, then the solar moon will either is in the south, exact south, or the another one exact north. But this case, of course, is the exact south. Okay, so direction, we face to the south. Then angle, tilt angle of the panel. What's the tilt angle of the panel here? Then you need to calculate for the value. Okay. You know the direction and which direction you want to face tilt angle. Because you are given the month, December. Okay. Wait a minute. Let me show you the lecture note. Okay, first, it give you December, but not give you exact value of December. Where should it be? Okay, so to find the declination angle, sorry, to find the tilt angle, you need to know the alpha. Okay, so to know the alpha, you need to know declination angle. So the date is just to tell you that it's December. So you can estimate in December what is the declination angle. If I look from here, and the middle should be around maybe December around here, 330 to 360, maybe around 22, negative 22 or negative 23. Okay, you can around pick this value. Okay, if you want to be safe, then you can use December 15, also okay. Because do not have a clear answer which is the optimal point for the entire December. Doesn't mean the middle is the best, because sometimes you will be something like this going down. Sorry, is something going downward. Okay, for the entire December. Okay, so we have to find a general point, maybe mid of December. Okay, so now our alpha, sorry, our Z, we focus to solar node, so 0. Our declination angle, just now we get from the graph, is around negative 22. Okay, our hour angle with for face to the solar node. So again, it is 0. So now we want to find the alpha based on this value. Okay. Yes, supposingly, you can assume the date, but of course in the exam, I will give you the exact date because I do not want to have a multiple answer from your side. It's difficult for me to match. I need to check your answer one by one. So in the exam, definitely exact date will be given. Okay. But of course, I won't tell you the noon or not noon. For example, this question, the only difference I will tell you in December 15th, something like this. Then you have to solve the question. Then whether face the noon or not face the noon is up to you. Okay, but definitely we will point to the noon most of the case. Okay, so now you calculate for alpha. I know that sine alpha okay, in the exam I say I will give you well-defined value. Okay, but in the real case, I mean that in the real life situation, normally a lot of assumption you have to make on your own. That's why the tutorial question come in this way. Okay, just give you a brief idea, and then you have to find your own assumption. Okay. Latitude is given 55° north. So 55 is positive. So what's the answer for alpha? 13, okay, 13 degree, or even solar known only 13 degree. So you can imagine how much solar energy they receive. Okay, so Malaysia is have plenty of this solar energy, but this location definitely not. Just the 13%. Sorry, 13 degree. Okay, so 13 degrees mean that this is the ground. The sun is angle between the sun and the ground is 13 degree. Okay, so if I want to get most of the sunlight, I need to put the panel perpendicular to the direction of the sunlight. So this is the tube angle. Okay, so beta will be equal to 90 minus 13. Okay, so it means that the panel, if you are located in that location, Copenhagen, okay, in December, so your panel must face to the south with the angle 77 tilted from the ground. Okay, so we well define the direction and the angle. Okay, so of course, let's say you do not know the day, and then in the real situation, you just refer to the direction and the length of the shadow. Then you can identify the angle, and then you can set the tilt angle. Okay, so just face to the direction of the sun. It just means that the shadow is always at the back. Okay, it's just the idea. I mean, the real case lah. We can do it in this way. Okay, but if you are not there, you cannot do this kind of experiment. So you still have to do the calculation. Okay, I think we stop at this question, question 3. Any other question? Are they here? I think quite not difficult, I would say. Okay, no question. Okay, good. Okay, so if no question, and then I think that's all for today. And thank you, Zhongyi and Jie, to provide the answer. Okay, thank you so much. And then thank you and see you next time. Bye bye.